Hey, today we're talking about 4.6, which is graphs of inverse trig functions, and we're going to do a little bit of review from all of chapter 4. Kind of a whole big summary in one couple problems. So to start things off, we're going to think back to inverse functions in algebra 1 and 2. So let's find the inverse function of y equals x plus 3. A couple ways we did this. The first way was, hey, we can just interchange x and y. So I get x is equal to y plus 3. And then what do? We solve for y. So we subtract 3 from both sides. We get y equals x minus 3. And that's the inverse of x plus 3. Another way we did this was we were like, hey, let's just plug in values for x into my original function and see what pops out. So we could plug in -1, 0, 1, and 2. I plug in -1, I get 2. Plug in 0, I get 3. 1, I get 4. And then 2, I get 5. And then to find the inverse points, the points for the inverse function, we just flip-flopped x and y. We took my y points and made them my x points. We made my x points, made them my y points. So I had 2, -1, 3, 0, 4, 1, 5, 2. And we can come back to the function that we found earlier for my inverse and see if that matches up. Well, I plug in 2. I get 2 minus 3, -1. 3, I get 0, and so on and so forth. So we're going to kind of use these tools that we've already known to find out the inverse function of some trig functions. So let's start with the graph of y equals sine x. So we know that to be this wave action graph, starting at 0, 0 and waving. But let's try to figure out what the graph of the inverse sine would be. We're going to do this whole flip-flopping x and y points. So let's start with 0, 0. If I flip 0, 0 in the x and y points, I still have the point 0, 0. Let's go to pi over 2. The x point's pi over 2. The y is 1. So I'm going to flip those. My x value is going to be 1. My y value is going to be pi over 2. So I have that point there, 1 pi over 2. At pi, my y value is 0, so I'm going to flip it to make the point 0 pi. And then for 3 pi over 2, well, at 3 pi over 2, my y value is -1, so I'm going to flip them. I have -1, 3 pi over 2. Then we can go in the negative direction. Negative pi over 2 has -1, so my y value is negative pi over 2, x is -1. And you can kind of see the pattern here. We're going to have negative pi, the point 0, negative pi, and so on and so forth. And now I can connect my points here, and it goes on forever, just like a normal sine curve. But let's think back to functions. Back in algebra 1, 2, wherever you heard about them first, the special test we used to see if a graph was a function was the vertical line test, saying I could draw vertical lines anywhere on the coordinate plane and it would only cross my curve once. Well, you notice sine x, yeah, I can graph all these vertical lines and only pass through once. But with the inverse sine, oh, look at that, I drew one and it already passed 3 times. So the full graph of inverse sine x is not a function. So this is why we introduce restrictions. We're going to restrict the y's here. So ooh, that was weird. Let's undo that. There we go. So we restrict the inverse sine graph to negative pi over 2 and to pi over 2. So I'm restricting, if we come back to my full graph, I'm restricting my inverse sine between the 2 teal lines. Why do I do that? Well, if we were to look at this restricted graph now, I see that it'll cross the vertical line test at any point because I've restricted it that way. If we think to the unit circle, why it works out really well that I picked negative pi over 2 to pi over 2 because, thinking to my all students take calculus, I'm restricting from negative pi over 2 to pi over 2. Which gives me points for a positive sign and a negative sign, which is good because we want to cover our bases and be able to take the inverse sine of some number and be able to figure out, oh, is it a positive angle, is it a negative angle? So those are the couple reasons why we chose the bounds negative pi over 2 to pi over 2. Well, what about cosine? Let's do the exact same thing. My cosine graph is given, so we're going to flip-flop points here. So at the point 0, my y value is 1, so my y value is going to be 1, my x value is 1 and my y value is 0. Pi over 2, the y value is 0, so at pi over 2, I have my point there. Pi, my y value is negative 1, so I have a negative 1 pi, and then 3 pi over 2, I have a 0. And then we can also go in the negative direction again. Negative pi over 2, my y value is 0. Negative pi, I have a x value of negative 1, and so on and so forth. We can connect those up. And we see right away again that this is not a function. I can draw that one vertical line there, and oh, look at that, I already passed 4 times. So we're going to restrict my inverse cosine graph to 0, from 0 to pi. Notice when I do that, I still have a function, and I am still covering the full unit circle from negative 1 to 1. So we choose to restrict the standard restriction on inverse cosine is 0 to pi. We're going to want to know these restrictions for later on when we start applying these to some problems. Well, what about tangent? Tangent's a little bit different because it's not a continuous function like sine and cosine. Well, remember right away that I have these asymptotes here at negative pi over 2, pi over 2. And then when we take the inverse of that, again, we can do the whole xy flip-flop point in order to graph this, in order to graph the inverse, and we get something that looks a lot like this. Still kind of a disco function, only this time it's flipped. For my bounds of this, we're going to use the asymptotes that were given. My upper bound is going to be pi over 2, and my lower bound is going to be negative pi over 2, just like the restrictions that we used for sine. And notice that my restrictions, negative pi over 2, pi over 2, correspond to my asymptotes. Then we can make sure, hey, with this restriction, does it stay a function? And yes, it does. I can graph all these vertical lines. It's only going to pass my function once. So let's use what we've just done to find all values between negative 2 pi and 2 pi for which, well, the first one we're going to do is that sine x equals a half. Remember, the first step whenever we had these before is we took the inverse sine of both sides, so we get the inverse sine of 1/2. So we draw our triangle here. Say this is my theta. Now, sine is opposite over hypotenuse, so my opposite is going to be 1, my hypotenuse is 2. Hopefully you can recognize this as a special triangle. With the theta, or x in this case, I probably should have made that an x, not a theta, where x is going to be equal to a reference angle of 30 degrees. Again, this is my reference angle. 30 degrees is my reference angle. So let's go to my coordinate field, my coordinate plane here. Now I know sine is positive. So using my all students take calculus, I know that I'm going to be in the first 2 quadrants, or where my 2 triangles are going to be. Now this is only dealing with the bounds of 0 to 2 pi. We're going to deal with the bounds of negative 2 pi to 0 in just a second. We'll get there in just one moment. So between 0 and 2 pi, I'm going to have 2 angles. The first one is in the first quadrant. The second one is in the second quadrant. So let's deal with the first one first. Well, hopefully that's pretty straightforward. That's a reference angle of 30, so my first answer would be 30 degrees. But remember, my bounds are in radians, 0 to negative 2 pi to 2 pi, so my first answer in radians is going to be pi over 6. Now let's deal with the second one. It's that red angle there. Remember, the reference angle is 30 degrees, or pi over 6, so I'm going to be a pi over 6 short of 1 pi, so my second one is 5 pi over 6. Now you may be thinking, hey, I got them both, I'm done. But we have to come back to our bounds. We're dealing with an interval of negative 2 pi to 2 pi. These two answers that I've just given in red only give the answers from 0 to 2 pi. Now how we deal with the negative 2 pi to 0 is we start at the positive x-axis and we go the other way around. So this teal angle is the first angle that I'm going to deal with from negative 2 pi to 0. Now you may be thinking, hey, the reference angle is pi over 6. So because of that, I'm a pi over 6 greater than 1 pi, or 7 pi over 6. And the last one, I have to start at positive x, go all the way around. And you may be thinking, hey, I'm a pi over 6 short of 2 pi. So because of that, it'll be 11 pi over 6. 1 pi over 6 short of 12 pi over 6, or 2 pi. Now you may be thinking, hey, why did I write them in that backwards way? Why did I put the 7 pi over 6 here and the 11 pi over 6 there? Well, the 5 pi over 6 and 7 pi over 6, they share this terminal side. One angle, the red angle, goes from positive x to that angle, the positive direction, and the other one starts at positive x and goes the opposite way around. So together, they add up to be 2 pi. One of them's the positive way, the other one's the negative way. So, I'm sorry, I brain farted. These should be negative angles. Please note that. I had forgotten the negative sign on 11 pi over 6 and 7 pi over 6. They're negative angles. So back to what I was saying, that those two angles, 5 pi over 6 and 7 pi over 6, should add up to 2 pi. Because one of them starting at positive x and going counterclockwise, the other one starting at positive x and going clockwise. But they should add up to 2 pi. So let's try this. Cosine x is negative root 2 over 2. Again, we start by saying, hey, take the inverse cosine of both sides. So I need to find out what my reference angle is going to be. Hopefully you can recognize by now that this will be a 45, 45, 90 triangle, or a reference angle of pi over 4, with my side lengths 1, 1, root 2. Now I know cosine here is negative. It's a negative root 2 over 2. So let's draw on my coordinate plane again. Using all students take calculus, cosine is going to be negative in the second quadrant and in the third quadrant. So I have my first angle. Remember, this is a reference angle of 45. So my first angle is that orange angle there. I'm a pi over 4 short of 1 pi. So my first angle is going to be 3 pi over 4. I'll put it right here. Then you're thinking, all right, the second one, all the way around. Now I'm a pi over 4 greater than 1 pi, or 5 pi over 4, excuse me. So remember, that deals with the angles from 0 to 2 pi. That's starting at positive x and going counterclockwise. That's the positive 0 to 2 pi. Now to do the negative side, the negative 2 pi to 0, I start at positive x. Well, let's use a teal color here. Start at positive x and going to the first terminal side, it's a pi over 4 short of 1 pi, or negative 3 pi over 4. And lastly, we'll do the same thing. Start at positive x, come around, and I'm a pi over 4 greater than 1 pi, or negative 5 pi over 4. Same thing, why did I write them that way? Well, this positive 3 pi over 4 and negative 5 pi over 4 share the same terminal side. This one right here. So the numbers, the 3 pi over 4, 5 pi over 4, should add up to 2 pi. It's a full circle. Box my answers so I know that that's it. Okay, so let's use some of these restrictions now and what we've learned before to solve these problems. The arctan of negative root 3. Now, just a word before we get started. This arctan, means the exact same thing as inverse tangent of negative root 3. The only difference is when you have arctan, it means your answer is going to be in radians. So when you see arc, you should immediately think radians. Your answer will be in radians. But other than that, it's the exact same thing. Now, right away, you could just plug this in your calculator, and you would end up getting a negative 60-degree angle. Or, because we're in radians, a negative pi over 3 angle. But if you don't have your calculator and you're like, well, let's try to do this without a calculator. That's great. Let's try that out. Let's think back to my restrictions of inverse tangent. Remember, my bounds for that one were a negative pi over 2 to a positive pi over 2. So let's draw out my coordinate plane. Negative pi over 2 to pi over 2. So I'm either going to be in the first quadrant or the fourth quadrant. Now let's think where tangent is positive and where it's negative in here. Using all students take calculus, all of them are positive there. Tangent's positive there. Sorry, that was a brain fart. Don't listen to me. Sorry, all students take calculus. That's a C. So tangent would be positive in the first quadrant and negative in the fourth quadrant. So I immediately know, hey, I'm going to be in the negative, in the fourth quadrant, the negative 60 degrees. Now how do I get the 60 degrees? We use our special triangles. This is my reference angle, theta hat. Arctangent is opposite over adjacent, so the opposite is negative root 3, and the adjacent is 1. The hypotenuse of 2. And hopefully you recognize that as your special triangle, with the theta here, theta hat being a 60-degree angle as your reference angle. Since I'm in the negative direction, I get a negative pi over 3. Let's do the same thing with inverse sine of negative 0.5. Now negative 0.5 is just negative 1/2. Let's write that out just so we can really see our side lengths. Again, you could just plug this into your calculator right off the bat, in which you should. It'll take 6 seconds. And you'll end up getting a negative 30-degree angle. Remember, we're inverse sine, so I'm answering in degrees here. But again, what if you don't have a calculator? Let's think back to my bounds on inverse sine. Inverse sine is bounded between negative pi over 2 and positive pi over 2. Because of that, my triangle is either going to be in the first quadrant or the fourth quadrant again. Using all students take calculus, I know that sine is negative in the fourth quadrant. So my reference angle, theta hat, is going to be in the fourth quadrant again. Using my special triangles, we'll get to special triangles in a second. Using my side lengths here of negative 1 over 2, sine is opposite over hypotenuse, so I have a negative 1, 2, and then square root 3 would be my x-axis. Hopefully you recognize this as a special triangle with the theta hat being negative 30 degrees. So that's how you do it if you don't have a calculator. Now this one looks messy. Sine of inverse cosine of negative 1/2. We're going to start from the inside and work our way out. So the inverse cosine of negative 1/2. I'm actually not even going to solve this, and I'll explain why in just a second. Again, you could just plug inverse cosine of negative 1/2 in your calculator, and you'll end up getting, I believe it's 120 degrees. But I don't even need to know that. Let's explain why. Let's draw out the coordinate plane again, and be mindful of where my bounds are for inverse cosine. 0 to pi. So I'm either going to be in the first quadrant or the second quadrant for inverse cosine. Well, inverse cosine of a negative here, so I know cosine is negative, which means all students take calculus-wise, I'm going to be here in the second quadrant. Now this is my reference angle, theta hat again. Because it's an inverse cosine of negative 1/2, cosine is adjacent over hypotenuse. I have an adjacent of negative 1, hypotenuse of 2, which makes it root 3 on the y. So this inverse cosine of negative 1/2, that's just an angle. That's just helping me set up my triangle. I don't actually need to figure out what that angle is. All I need to use this inverse cosine business for is to set up my triangle. Now I just take the sine of this reference angle. I've already set up all my side lengths, the sines, everything's ready to go. I just have to take the sine of that reference angle. And the sine of it is root 3 over 2. And that's my answer. I don't have to figure out what the inverse cosine of negative 1/2 is. Don't do more work than you need to. So this part right here is just to kind of help you and give you an example of where my buttons are in my calculator. So you could punch in, as long as you're in degrees here in your calculator, the inverse sine of 0.1702, and you'd end up getting 9.8 degrees. However, if you didn't have a calculator and you wanted to figure out, say, the sine of this, like, hey, why is it a positive angle here? Well, think back to my bounds here for inverse sine. Negative 2 pi to 2 pi. So I'm either in the positive axis, first quadrant, or the fourth quadrant. Well, the inverse sine here is a positive number, so I know I'm going to be in the first quadrant, which corresponds to this positive angle that I have. So with this in mind, what sign, S-I-G-N here, would it be negative or positive for the answer of inverse sine of negative 0.4664? Well, remember, using my bounds, I'm either going to be in the first quadrant or the fourth quadrant, and I know sine is negative in the fourth quadrant. So I should expect to get here a negative answer, a negative degree. And it just so happens, if we plug in our calculator, we get negative 27.8 degrees, which makes sense, because knowing our bounds, and that sine here is negative, we should end up getting a negative degree. Go ahead and write your summary and any questions you have, and then please try out the homework for tomorrow.